For a long time, the research that we have been doing was purely driven by curiosity, and this led to the discoveries that were eventually honored by the Nobel Prize. But is there possibly an application that could make a difference to people's everyday life? And it took about 15 years to eventually come up with an answer of how this very capability, attosecond metrology, might enable us to improve our ability to protect human health. Can we transform healthcare from its current mode of operation to a new mode of operation? This is the goal that we have set ourselves, to come up with a method that is cheap enough, comprehensive enough, that is non-invasive, that is risk-free. Therefore, it is absolutely essential that developing disorders are being captured, are being recognized at the earliest stage of their development, when intervention offers a much higher success rate. It turned out that actually attosecond metrology can not only capture electronic motions, but can also trace the oscillations of the electric field of light, of even visible light. We actually realize to measure minuscule changes in the molecular composition of human blood. And we have been working now for 10 years to identify correlations between developing disorders and changes in the molecular composition of human blood, which becomes visible in the so-called infrared fingerprint of human blood. And we have indeed found that different types of cancers do induce a very characteristic change in this infrared signal, what we called infrared fingerprint of the blood sample. And this characteristic change can be assigned to this particular disease. The concept seems to be pretty general. Whenever a severe disease occurs, this changes the molecular composition of human blood. If the molecular composition of human blood is changing, so does the infrared fingerprint of this blood sample, which we can now capture with our attosecond metrology. One of the main motivations was the truly outstanding world-class healthcare system in Hong Kong. Hong Kong is an ideal location because so many different ethnicities are here around. This is probably the best place in the world where the universality of an approach in medicine can be proven. We would like to implement 3 essentially identical, highly standardized longitudinal cohort studies with 15,000 participants each. And if everything goes according to our plans, then by 2035 we should have this screening algorithm in place. With it, the healthcare systems in Budapest, Munich and Hong Kong could potentially start a broad population screening to protect the population in a much better way than it is possible today. My interactions with the leadership of Hong Kong U gave me the strong impression that Hong Kong U is determined to foster forefront research and create ideal conditions for advancing the frontiers of science, technology, medicine in all possible ways, by attracting leading scientists, by attracting best young talents, and by creating ideal research opportunities here, creating the necessary infrastructure and pulling together, encouraging all scientists working in the different areas that can contribute to the success of an interdisciplinary endeavor like this one. So I think Hong Kong U is really the ideal place to tackle this endeavor.